In this video, we're briefly going to look at binary arithmetic. And the reason we want to do that is because we know at some level our computer is doing these arithmetic operations, addition, subtraction, more complicated operations on binary numbers. So we want to have at least a base understanding of how the computer is accomplishing this. And what we're going to see is that our rules are exactly the same as they are for decimal arithmetic, but because we're working in a different number system, things are going to look a little different at first. So let's start over here with this addition on the left, and we're going to work our way over to the right. So as we're doing addition, it's going to be the same basic process as what you learned in grade school. We're going to start with the least significant values, and we're going to work our way towards the left. As we're doing that, if we have to carry over any values, we're going to indicate that by carrying over up here on the top. So let's go ahead and work through this one step at a time. So we start in our ones place. We see we have 1 plus 0, which is just going to be 1. So we can write a 1 down here, starting our sum. In the next values in our twos place, we have 1 plus 1, which we know is 2, but we can't represent a 2 by 1 with one digit in binary. So we know that is 1 0, so we put a 0 here, and we have to carry the 1. So that's exactly the same as if we were doing decimal arithmetic, and we had, for example, 6 plus 6. So we can't represent 12 with one decimal digit, so we have to carry over to the tens place, and then we have the 2 in the place we were at. So continuing that same process, now in our fours place, we see we have 1 plus 1. So again, that's 2, so we put a 0 here, and we carry the 1. Now we have 1 plus 0, which is going to be 1. And so what we can always do is we can always convert these binary numbers to our decimal equivalents, and we can sort of verify it that way. So if we converted 0011 to decimal, we would see that that is equal to 3. And 0110 is equivalent to 6 in decimal, and 1001 is equivalent to 9. So of course that checks out. 3 plus 6 in decimal does equal 9. So let's move on then to our other two operations. So the middle operation we see is subtraction. So again, we're going to start from the right and work our way towards the left. So we have 1 minus 0, which is just going to be 1 in our ones place. Now for the next place, we have 0 minus 1. So we don't really have enough in this 0 up here at the top to subtract anything from it. So what we can do though, we notice we have a 1 over here, is we can borrow from that place that's 1 to the left. So what we can do is basically say here we have a we're getting rid of that, we're bringing it over here, and that's equivalent to a 2 over here. The same way if we had to borrow in doing decimal arithmetic, we would get rid of the number where we got rid of 1, and instead of a 2, we would put a 10 there. So now we have 2 minus 1, which is of course going to give us a result of 1. 0 minus 0 is 0, and 0 minus 0 is 0. So again, we can do a similar thing to what we did with the first operation, and we can convert these numbers to their decimal equivalents. So 0101 is a decimal 5. 0010 is a decimal 2, and 0011 is a decimal 3. So again, confirming that we did that binary arithmetic correctly. So now let's go on to our third and final example here. So this is another addition, so we're going to follow the same rules we saw previously. So 1 plus 1 gives us a 2, so we put a 0 here and we have to carry the 1. 1 plus 0 plus 1 is again 2, so we put a 0 and we carry the 1. 1 plus 0 plus 1 is 2, so we put a 0 and we carry the 1. And 1 plus 1 plus 0 again is 2, and so we carry the 1. And so the main reason I put this example in here is to see that we could potentially have an issue if we only had 4 bits available to represent the answer. So let's go ahead and convert this to our decimal equivalent sort of as a check. So let me go back to our pen and change to a different color. So our 1001 is going to be a decimal 9. Our 0111 is going to be a decimal 7. And if we only had 4 bits to represent our answer, then that, of course, 0000 is 0. So 9 plus 7, of course, shouldn't be 0, so something has gone on there. The issue is that really we have another bit which is in a more significant place here, but if we only have 4 places available, we don't know what that bit is, so we would end up with some error. And so the way that computers would often handle this is they would raise some flag, so there's a flag bit that would be set to say that our result down here has overflowed. So we went to more places than we had room for. And sort of relating back to one of our previous videos as well, let's say we only had 4 bits in our output. Well, we know that the maximum value that we could represent then would be 2 to the power of 4 minus 1. So 2 to the 4th is 16, minus 1 is 15. So 15 would be the maximum number that we could represent with 4 bits. And so, of course, if we do this addition in decimal, 9 plus 7, we get 16. So as expected, we're just a little bit outside of what we can represent with 4 bits.